Hey, welcome back. Today let's talk about algorithms. What is an algorithm? Well, an algorithm is basically a set of instructions that when you follow or when the computer follows this set of instructions, it solves a particular problem. What are examples of algorithms in our everyday life? Well, think about sorting algorithms or sorting in general. Think about your laundry for a change, right? This is a completely analog, non-digital activity of sorting laundry, socks that match each other. You can sort laundry by the temperature that they're supposed to be washed at. You can sort laundry by color. And these are all examples for, well, sorting algorithms, right? If you sort a laundry basket by color, it means that you separate probably the white laundry from the colored laundry. So then that's this very simple set of instructions how to sort this into two piles. Every white laundry item goes in one basket and all the other non-white laundry items go in another basket. What about lists of some sort? Think about your contact list in your smartphone. This is also ordered. It's sorted by alphabet. Probably, right? Or maybe by the most recent call or contact that you had. So if we have a parameter there, we've got a parameter to sort a list by a certain criteria, like when did I call this contact last? So the contacts that have been contacted by me recently are up in the list and everybody else is down until we reach the bottom of the list of people who we never called. So a sorting algorithm is probably something that you encounter every day without actually knowing it. Think about any kind of list that you encounter, and chances are the list is sorted by some criteria. For example, when I'm doing my bookkeeping, I have to order the list of the sheets of invoices, the hard copies, the printed out copies, because it's 2023 now when I'm recording this, but we still need to print out invoices and we need to bring them in order and then ship them over to my accountant. And then she does some magic stuff with it and then I get the invoice and I pay it basically. But again, this is a list of stuff that we need to order by date in that example. Okay, so sorting algorithms, a very typical type of algorithms, not just in the digital world, but also in our analog world. Think about the laundry basket there. What else? Well, a searching algorithm. If you search for a certain book on Amazon, you type it in the search bar there, and then you get the list of matches, hopefully of the book that you searched for, but maybe about other books also that might relate to your search there. Or think about finding contacts in a phone book, in a really printed out phone book. It's probably not existing anymore. And yes, I'm that old. But now think about a dictionary, right? You're looking up a word in a dictionary. So you have a searching algorithm there without really thinking about it too much. What do? Well, you start with the first letter, then you flip to the page where this first letter appears, and then you sort and scan through the words for the second letter and the third letter until you reached the that you were looking for. And again, that's a kind of antiquated example there because nobody's using analog books as dictionaries any longer. But it should illustrate the point. What other examples are there for algorithms in our everyday life? Well, think about recommendation algorithms. Right now we're getting into this area where we had some recent discussions there about the ethics of AI, the ethics of algorithms. Think about your Netflix or Amazon Prime or Apple TV or whatever you're using streaming service. Usually you get a list of recommended TV series or movies there based on your previous viewing history, right? So there's an algorithm there, a set of ordering instructions that basically take a look and search for your previous TV shows and movies that you've been watching, and then finds other stuff, other movies and other TV series that are related, that other people who have been watching these TV series have been also watching. And then they're recommended to you. Another example for a recommendation algorithms is, again, on any e-commerce site like Amazon, the suggested products on these websites, right? If you're looking for a certain product, you get recommendations for other products that are somehow related to that product and that people who have been interested in or even purchasing this specific item they were showing some interest in these other items as well. So that's why Amazon is showing them to you as well. Other examples for algorithms in our everyday life. Well, think about navigation algorithms, right? Before, like, I don't know, 10, 15, 20 years ago, before the smartphone, we had GPS devices in our cars. Now it's all built in, of course, into our smartphones. But still, you need an algorithm, a set of instruction that's sort of built into the software there to find a way from point A to point B. And then the question is, if there are several options, which is usually the case, if you're not living just on the one single road in your area, but if there are several roads, there are several options that this GPS program could choose, like Google Maps or Apple Maps. And the question then becomes, well, what's the criteria? What's the parameters that are used and taken into account in order to suggest a route to you? Is it the fastest route? Is it the route that's the shortest distance, regardless of the time that it takes you? Does it go through any crowded areas, or does it know about any restricted areas? Does it go through pedestrian zones where you're actually not supposed to be driving with your car? Does it give you options to not just use your car, but maybe use some public transport? Okay, so these are all parameters that are sort of taken into account, that should be taken into account when we are talking about navigation algorithms. And these are examples, like the recommendation algorithms and the navigation algorithms are examples where it's easy to understand them in principle, but very hard and complex actually when you are supposed to be programming such an algorithm. And that's not usually what you're doing. You're using a service like Google Maps or Apple Maps or any other kind of navigation service. If you want to include that in your app, into your website, you usually don't have to program that navigation algorithm yourself. You're just using something else as a building block one more time. And one last kind of algorithm that I want to mention in our everyday lives is a prediction algorithm, like the weather forecast. Well, believe it or not, there's not just humans there doing some calculations. There's usually very complicated mathematical models that take into account very different data points of temperatures and humidity and what else. And then they calculate the model of how the weather is probably going to progress, or what's the chance of rain today, which is a very simple number as a result, but taking very complicated input data as the input in order to make these calculations. Traffic predictions, right? Usually when you are when you're commuting to work, chances are that your navigation app has some historical data on your route that would be the fastest route to your working place, to your office. What's the traffic at this time of day, at this day in the week, usually? And should I suggest another route there because it will take you longer there. So based on the historical data, prediction algorithms like stock market analysis, right? How's the stock market going to behave? What's a specific crypto coin going to do, which has some big financial impact, of course. And there's lots of chances to create all kinds of problems, and I have no idea about the crypto market or about stock market algorithms in particular. But you get the idea. And again, an algorithm, all these kinds of examples I'm giving you are examples for sets of instructions that might be very easy, like sorting your laundry list between white and non-white items, or very complicated and having a very complicated weather model there. But the idea is always take some input data and then process the data somehow in order to create some kind of output, like a recommended movie list or an ordered list or a sorted list of items or a prediction for maybe the chances of rain today. So when you're interacting with your smartphone or with the computer, take note and pay attention to the processes and the patterns of these algorithms that are most probably not exposed to you directly, but every time you get a list, every time you get a feed of items, of products, of movies, of videos, what I think about, well, okay, there's some rules there in place, some algorithms that actually had determined this list. And the question then is, what kind of data was this list based on? Am I getting more of the same content, more of the same items here recommended to me? And what is this doing with me? Am I in my filter bubble? It's also a very often quoted word, I guess. But it's true. I mean, the algorithms that are sort of based on the social networks that we're using, on the movies that we're watching, they work based on the stuff that we are getting them as input data. And they try to, suggest just something that keeps us on the form or on the service that we're using in order to engage, in order to spend time there, in order to watch commercials or whatever the financial and the sort of economical impact and reasoning behind this. But yeah, we need to be aware of that these algorithms are in place and that there's somebody having a in keeping us there and therefore showing us stuff that increases the likelihood that we're going to spend more time with the product, with the service, with the platforms. But yeah, if we are sort of aware of that and if we pay attention to this, and also if we are paying attention to our daily life and think about, well, if I had to tell somebody, explain somebody how to do this simple task that I'm doing, ordering, sorting laundry, what would be the rules there? What's the set of instructions that I would need to give somebody in order to solve this problem of sorting the laundry? That's basically the way to think about algorithms. And then the easy part is actually to translate that into code, right? But the idea first is the algorithm itself is an abstract set of instructions. It doesn't really matter the programming language or any kind of frameworks. It can make it easier or not that easy depending on the language and on the framework. But the idea is always this algorithm is a set of instructions. And so we need to think about what's the logic behind, what do we need to do first? What's the condition of to sort your laundry there? What's the parameters? What's the input data that's coming in? And what kind of processing, what kind of instructions and rules do we need to set into place in order to get the expected outcome?